Okay, today I'm going to go over topic 3.1, periodic phenomena. So a periodic relationship between two variables occurs when the output values demonstrate a repeating pattern over successive equal length intervals. So this can be lots of different things, and we're going to see lots of scenarios that are modeled with periodic functions. But you can think about daylight, how sun goes up, sun goes down, sun goes up, sun goes down on equal length intervals. The rotation of the earth, the breathing in and out, your heartbeat. There's so many things that are repeated in roughly equal length intervals. The period is how long it takes for a function to start repeating itself. So in this first example, we have a graph with a period of 4. Okay, so from -1 to 3, from 3 to 7, we see a pattern that then repeats itself. So if I want to draw 2 additional ones, we're just going to repeat the same pattern. So up, over, down, up, over, down. Okay, we have another graph that is repeating itself. And it says, what is the least possible period? Well, I see a distinct pattern here that starts to repeat itself after this point. So from 1 to 6, which would make this have a period of 5. And then we can use that to find values that aren't even on the graph. Okay, so if we have a period of 5, I can find the value of g of 14 by looking at, if I kept going, what equivalent value between 1 and 5 would be equivalent to 14. There's different ways to think about this for sure. How I think about it is how many periods can I, in this case, subtract from here to get a value that's on my graph. So in this case, I'm going to take that 14 and subtract 2 periods of 5, because that would be subtracting 10. So this would equal g of 4. And then I can go to my graph and find g of 4 is 7. With 72, I can subtract 14 periods. Because 14 times 5 is 70. So 72 minus 70 gives me g of 2, and then I can go to my graph and evaluate that at 6. For 17, I'm going to add some periods of 5. In this case, I'm going to add 4 of those, because that would give me a positive 3. So g of 3, according to my graph, is 7. Now we have a similar thing. We have a graph that has a period of 5. We don't have the graph, but we have some selected values. So we know this is going to repeat itself every 5. So if I can add or subtract periods of 5 to arrive at one of these x values, that will be repeated. That'll be equivalent to what we see here. So for h of -2, if I add 5 to that, that's going to be h of 3. Which in my chart I have 3, so I can evaluate that to be 0. Okay, h of 6 is not in my chart, but 1 is. So I can take 6 and subtract a 5 to get 1 and have an output of -2. Okay, for h of 9. Okay, I've got a 4, so I'm going to take 9, subtract my 5. Okay, h of 4 is on my chart, so I get 3. And then h of 3, I don't have to do anything because that's already there. Okay, this one, h of 5k minus 3. So I'm going to rewrite this as -3 plus 5k. So that 5 is my period. So we're taking -3 and I'm adding or subtracting some number of 5s. Well, h of -3 I don't know. But whatever this is equal to, it equals h of negative 3, because it would be whatever value is plus 5 or minus 5. So now I just need to try to find negative 3. Okay. So I can add, if I wanted to add 5, that'd get me 2, but that's not there. But if I add 2 5s, that would give me h of 7, which is in my chart, which is going to equal 2. Kind of an interesting thing happens with periodic functions in that they are horizontal translations of themselves. So like this graph here, just as an example, I could shift it over, in this case 4 units, and it would end up right on itself. So we can use the same notation that we used for a horizontal translation and say h of x is also equal to h of x minus 5, or h of x equals h of x plus 5. Okay, either way, you'll end up with the same graph. Okay, next, the graph of f is periodic on the domain for all real numbers. Two full periods are shown. Find all the values of f that yield an output value of 1. Okay, well, an output value of 1 would be here, 1, here, and repeated. So I'm going to write this as, so we've got a period of 4. Okay, so if I'm starting at 2, it's going to be 2 plus 4 again, plus 4 again, or take 2, subtract 4. So a way to say that is to write plus 4k, where k is an integer. On your AP exam, you're going to have 4 free response questions. Question 3 is going to be a trig graph, and we're going to be dealing with that. So we're going to take the pieces that we've already talked about with the repeating patterns to start working on these free response questions. So this says, the figure shows a large clock mounted on a vertical wall. The clock has an 8-inch long moving minute hand. So this guy here is 8 inches. The center of the clock is 120 inches from the floor. At time 0, the minute hand is directly up at 12. However, the clock is not working properly. The minute hand moves twice as fast as it should. Thus, the next time the minute hand is directly up is at 12. Up to 12 is at 30 minutes. As the minute hand moves, the distance between the end point and the minute of the hand vary periodically. All right. So before I get into the questions, I'm gonna label some more stuff. So if this is 120 to here, the bottom of the tip of our minute hand is going to be 8 inches below that, which is going to be at 112. And then my top is going to be 12 inches or 8 inches above the 120 at 128. Okay, and that's my 120 there. Okay, so my clock is going to be at 128, then it's going to go back down to 112, then it's going to go back 8, and so on. So I'm going to draw myself a little graph here. Okay, so this starts at the top, it goes down, and then it's going to go back up again. And we were told it takes 30 minutes for this broken clock to do that. Okay, well if it goes from here to here in 30, it's going to go to the minimum after 15 seconds. It's going to hit the midpoint here halfway in between those. So at 7.5 and at 22.5. Okay, so our first task is we have the graph of 2 cycles of a periodic function. Points F, G, J, K, and P are labeled. We are going to determine possible coordinates. Okay, because this is going to repeat itself, there's an infinite number of correct solutions here, but we have what we need here. Notice F starts at a maximum, so we want to make sure that our graph starts at a maximum. So my points, this is going to be F, this is going to be G, this is going to be J, this is going to be K, this is going to be P. Okay, that's what I have here. So transferring that information, F, the x coordinate is going to be 0. The height was at the maximum at 128. The next point occurred 7.5 minutes later at that midline of 120. J is down at the minimum. That happens at 15 minutes. K is at 22.5, back up at that middle point. And then P's back at the maximum, exactly 30 minutes later. Okay, next it says, refer to the graph of H in part A. T coordinate of G is at T1. The T coordinate of J is T2. Okay, so we're talking about this little segment. Okay, it says, which of the following true? Is our interval positive and increasing, positive and decreasing, negative and increasing, negative and decreasing? Well, my hand is always above the x-axis, so it's going to be positive. Okay, and for this interval, my graph is decreasing. And then last, describe how the rate of change of H is changing over T1 and T2. So rate of change, we're looking at the concavity. If the graph is concave up, the rate of change is increasing. If the graph is concave down, the rate of change is decreasing. Our graph is concave up. On our interval, the rate of change is increasing. Okay, and that was 3.1 periodic functions.